So today we're going to kind of step back a little bit and go back to our factoring. But this time we're going to solve quadratic equations by factoring. Now, to do that, we're going to need all of our equations in standard form. Now, the standard form of a quadratic equation is ax squared plus bx plus c, but this time is equal to 0. And of course, we know that our lead coefficient doesn't equal 0. Okay, so for example, x squared plus 2x plus 1 equals 0 is the standard form of a quadratic equation. Or if you have 3x squared plus 7x plus 2 equals 0. That's the standard form of a quadratic equation. Okay. Now the reason we want it in standard form is because it sets us up for our zero factor property. What that says is that, let's say if we know that some variable a and some variable b, they represent real numbers. Okay, it could be a fraction, it could be a decimal, it could be an integer, it could be a whole number, it could be 0. It doesn't matter. Just we know it's a real number. We know it's not complex. And we also know that if you multiply them together, they equal 0. Now, the only way this is possible is if either a equals 0, b equals 0, or they both equal 0. Because there are no other two numbers you can multiply that would give you 0 except one of those being 0. Then a equals 0, b equals 0, or both. And that just shows the end of it. Zoom out a little bit. All right, leave that up for a few more seconds. So let's say, for example, if we were asked to solve x minus 3 times x plus 1 equals 0. Helps with the fading in and out. Sometimes that helps. see. Okay. It doesn't fade out as much. That helps a little. Okay, so the first you want to do, since it's already factored, you set both to 0. So that means for this to be true, we can make either x minus 3 equals 0, because this is 0 times, and it doesn't even matter what this is. 0 times anything is going to be 0. Or we can make this one 0. And if this is 0, it doesn't even matter what this one is, because 0 times anything would be 0. So that means x minus 3 can equal 0, or x plus 1 can equal 0. Either one of those would make this one true. Okay, so if we add 3 to both sides, I mean x can equal 3. Or if we subtract 1 from both sides here, x can equal negative 1. Okay, so your solution can be either negative 1 or 3. Okay, so what if we wanted to solve? Slide that up a little bit. Say 12n minus 4 times 6n minus 2 equals 0. Okay. Just like we did before, we just set both to 0. Okay, so that means you have 12n minus 4 equals 0, or 6n minus 2 equals 0. Okay, so if we add 4 to both sides, then divide by 12, you have n equals 4 over 12, which if you simplify it, n equals 1/3. Or if you add 2 to both sides here, then divide by 6, we have n equals 2 over 6. If you simplify that, you end up with n equals 1/3. So your solution for this one is just 1/3. So just because it appears twice, you only have to put it as a solution once. So in this case, both of those would equal 0. Okay. Any questions on either one of those? All right. Okay, so what if we had to solve, say 4w times 10w minus 7 equals 0. Let's see if I can bring this to see the whole thing. There we go. Just like before, we set both of them to 0. Okay, so that means you could have 4w equals 0, or 10w minus 7 equals 0. Okay. So for this one, if we divide both sides by 4, we just end up with w equals 0 over 4, or w equals 0. If we add 7 to both sides and then divide by 10, we have w equals 7 over 10. Okay, so our solution here is just 0 and 7 over 10. So when it's already factored for us, all we have to do is just set all of those factors to 0, and we're all set. The trouble comes when they're not factored for us, and we have to go through all the trouble of factoring. That's when all the extra work comes in. Okay, I'll leave that up for a few more seconds. Alright, looks like everyone's done writing. Oops. Okay, so let's say if we wanted to solve a squared minus a minus 20 equals 0. Okay. Now, unlike the ones before, this one's not factored for us. So all we have to do is factor the left-hand side. So we're going to factor a squared minus a minus 20. Okay. So we see there's nothing in front of the lead coefficient, the lead variable. So that means we just have to find two numbers that forgot to put what my a and b is. Okay, so we know here our b equals -1 and our c is -20. So we have to find two numbers that multiply to equal our c, and those same two numbers add to equal our b. Okay, so for 20 you have 10 and 2, you have 5 and 4. So we know 5 times 4 gives us 20, but it's negative, so we know at least one of those would have to be negative. And we know that our largest value would have to be negative, since that's a -1. So we have -5 and 4 is -20, and -5 plus 4 adds to -1. So that means this will just become a minus 5 times a plus 4 equals 0. Okay. Just like we did before, we just set both to 0. Okay, so that means a minus 5 can equal 0, or a plus 4 can equal 0. Either one of those will make this true. So if we add 5 to both sides, we know that a can equal 5. Or if we subtract 4 from both sides, a can equal -4. Which means your solution is either -4 or 5. Now, it doesn't matter normally what the order is, but with Newton they may decide to be picky, so just to be on the safe side, I'd plug it in order. Okay. Any questions on this one? All right, I'll leave that up for a few more seconds. Right, so let's say for our next example, there we go. If we wanted to solve 3a to the third power minus 18a squared plus 24a equals 0. Okay. Now the one thing we know is that it's not in standard form. It has to be something a squared plus something a plus c equals 0. So we can factor an a out of all three terms. But then we can just use the a times c method after that. But if we can get that 3 out of there, if we can factor 3 out of each term, we don't have to worry about the a times c method. Okay, so we factor out 3a from each term. Okay, so if we factor out a 3a times a squared will give us 3a to the third. 3a times negative 6a will give us negative 18a squared. And 3a times 8 will give us 24a equals 0. And you can always distribute it to double check and make sure you factored it correctly. Okay. So you always want to try to remove the greatest common factor. It's if it's necessary. Or not even necessary if possible. Necessary is not the right word. Before applying a times c method. Okay. The a times c method would work, it's just a whole lot more steps. Okay, so now we don't have to worry about factoring out that, we just have to factor this part. Factor a squared minus 6a plus 8. Okay. So for our a squared minus 6a plus 8, we know that our b is equal to negative 6, and our c is equal to 8. So that means we have to find two numbers that multiply to equal your c. Bring that up a little bit. And those same two numbers add to equal your b. Yep. So 4 and 2 gives us 8. But we see that when they add, they have to be negative, so you just make both of those negative, and it should work. So you have negative 4 times negative 2 is positive 8. And negative 4 plus negative 2 is negative 6. Okay, so we know that this, always remember the value that you factored out. So you have 3a, and we know a squared minus 6a plus 8 just becomes factor a minus 4, a minus 2 equals 0. Okay. Now it doesn't matter if you have 4, 3, 4, 2, however many factors, you still do the exact same thing. So once you have it all factored out, once again, you set all factors to 0. Okay, so factoring it out is your immediate goal. And once you factor it out, it kind of goes downhill from there. So that means 3a can equal 0, or a minus 4, bring that up a little bit, can equal 0, or a minus 2 can equal 0. Any one of those would work. Okay. Now if we divide both of these by 3, a equals 0 over 3, or just a equals 0. Since 0 divided by anything other than 0 is just 0.
Can't you divide this one like 3a up there?
Oh yeah, if you wanted to divide just the 3, you could. But you couldn't divide the variable.
Oh, okay.
Yeah, but if you want to divide the 3 right from the beginning, let me move that down. If you want to divide both sides by 3, you could have just had a times that. Okay, so the only reason you couldn't just get rid of the a is because up here, oh, let me go down a little bit more, is you still had an a in each term. So it's kind of like you're just throwing it away if you just divide it away. So yeah, you could have gotten rid of the 3, so it still would have worked. Okay, so a minus 4, add 4 to both sides. You know, a equals 4. Add 2 to both sides here. A equals 2, so which gives you a solution of 0, 2, and 4. Again, it shouldn't matter what order it's in, but depending on how Newton is programmed, I'd put it in numerical order just in case. All right, leave that up for a few more seconds. Okay. Any questions on this or anything so far? No. All right. All right, looks like everyone's done writing. Okay, so what if we wanted to solve (12x squared plus 28x equals negative 8? Okay, so the first thing you always want to remember is always solve it in standard form. And that's your ax squared plus bx plus c equals 0. So in other words, bring everything to the left side and make it equal to 0. Okay, so if we add 8 to both sides, we end up with 12x squared plus 28x. I'll just write it out. So now we end up with 12x squared plus 28x plus 8 equals 0. Okay, so we can't factor 12 out of each term, so that kind of forces us to use the A times C method. But we can make our numbers a little smaller by factoring a 4 out of each one. Okay, so if we factored out a 4, 4 times 3x squared will give us our 12x squared. 4 times 7x will give us our 28x. And 4 times 2 will give us our 8. Okay. Now before we factored out a variable, so we didn't divide both sides. Here, we just factored out a number. So as long as we just factor out a number, we can divide both sides by 4. Okay, so we end up with 3x squared plus 7x plus 2 equals 0. Okay, so make a quick little note that we didn't factor out a variable so we can divide both sides by 4. Okay, now if we factored out a 4x, we wouldn't be able to divide both sides by 4x. We could have still divided by 4 if we wanted to, but we didn't have to. Okay, so now it's a lot easier to use the A times C method here than it would be to use it up there. Okay, so now here we can use the A times C method. Where we have our A is equal to 3. We know our B is equal to 7. And we know our C is equal to 2. Okay, which means that our A times C is going to be 3 times 2, which is 6. Bring that up a little bit. So that means we have to find two numbers that multiply to equal our A times C. And those same two numbers add to equal our B. Okay. So this one's pretty straightforward because we just use 6 and 1. So 6 times 1 is 6, and 6 plus 1 is 7. Now with the A times C method, remember that once we do that, we replace our B term. So we're going to replace 7x, which is our B term. So that means this will become 3x squared plus 6x plus 1x. Oh, just the 1 right here. Yep, because of that one. So we're going to replace that middle term with our 6 and 1. Uh-oh. You don't have to put the 1x, but I like to do it anyway. Plus 2 equals 0. Okay. Now once we do that, now we just go to our factor by grouping.